All right, let's go ahead and get to our notes. We get to do math today. Yay. We get to solve for a variable and everything.
You say math like algebra?
Like algebra math.
That stuff.
I know.
I can't wait. I might actually understand this lesson. Was our last one just Monday last year?
The last 17 should be in
As
your
long as
notebook.
there's no conclusion.
Oh, it should be in our notebook?
It should be good.
They've already been graded this year.
Oh, really? Okay, wait, mine isn't going yet. Wait, no, it's not.
It's all about.
Okay, so one of the things that you're often asked to do is calculate the sample size needed to get to a certain margin of error. So they'll say if we want to estimate the average IQ of seniors at G, okay? We want to know how many people do we need in our sample if we want to estimate it within 5 points. How many people will we need? So this is something that you will likely be asked to do. Okay? Find out how many people. So your margin of error part of the equation is just that after the plus or minus. So when you're looking at your confidence interval equation and you had our point estimate plus or minus this part, this is your margin of error. So if they're telling us what they want for a margin of error, we should be able to solve for sample size. That's what you're trying to do here. So, just to remind you of a couple of things, this value z asterisk is the critical value. You find this on the infinity line of the t table. So that's where you find that critical value. So they will tell you what percent confidence level you're using, and you just look this up on the t table. The other thing, this p hat, sometimes they tell you, sometimes they don't. So if p hat is not given, we'll use p hat is 0.5. So if we don't know how likely an event is, we assume it's a 50-50 chance. Each outcome equally likely. Okay? So if they don't give it to you in the problem, that's what you'll use. On your problem set for today, there's one where you need to use that. The other ones, it tells you the probability. Okay. So most of the time, like I say, you're solving for n. So this is just an algebraic equation. You're going to have numbers in all of these other places, and you're solving for this one. You will do the same steps every time because you're always solving for n. So if you want to, what you can do is you can solve this formula for n, and then you just plug it in to where it's already solved for n. So let me show you what I mean by that. So if I want to solve for n, first thing I'm going to do is move this over to the other side. So I'll have margin of error divided by the z critical value is equal to all of this under the radical.
So why is it not written like that then?
Because this is how it's written in the confidence interval equation, and then it's just sometimes you're asked to solve for that, and so we're just going to show how to solve for it.
So should we write that this is how to solve for n?
That's what I would do, yeah. So then, I'm trying to get n by itself, so I'm going to square each side. So then we have basically at this point, we would multiply both sides by n, and then divide by this part over here to get n by itself. So we would end up with n is equal to p hat times 1 minus p hat all over this. So when you're asked to find a sample size, you can just plug into this. This is how you're going to be able to find it on the formula sheet, is this up here. So you can just put all the numbers in first and then solve for n. Or if you would rather just do it this way, or your notes, you can do that. It's totally up to you, whichever way you'd rather do it.
Did you have to divide by z, or could you just left it over there?
You're going to have to divide it.
Because wouldn't just the z's can go back around again.
But you have to, it has to be z squared that goes back in up here. You have to remember that.
If you square it.
Yeah. Just, a lot of people forget to square it whenever they do that. Okay, so let's look at an example with this. Okay, so example 1 over here. So suppose you wish to determine the proportion of college students in your state who receive some form of financial aid. You want to be 98% confident of your results and have a maximum error of 5%. Calculate the minimum sample size needed to meet these requirements, given that the financial aid office at a local university estimates the percentage to be 78%. Okay, so when I see this 98%, and I'm dealing with proportions, that tells me I'm looking for a z critical value. And I'm going to look this up on the table. So I'm looking on the T table, infinity degrees of freedom, looking at 98%. There it is, right there. So 2.326. That's my value. Then we have this maximum error of 5%. That's our margin of error. You want to make sure you make that into a decimal, 0.05. Don't just put it as 5. And this value here, the 70%, is our p hat. So if we plug this into this formula up here, we get 0.05 equals the p hat, or the
0.78.
0.326 times 0.78 minus 0.78 all over n. And then you're just solving for n. So to solve for n, we just divide each side by the critical value. So to get rid of the radical, we just square each side. And you get n equals so you'll see that ends up being exactly how we had it over here. The p hat, 1 minus p hat on top, margin of error over our z critical value squared in the denominator. So it's the same thing. It's just whether you want to plug in the numbers and work it, or if you just want to plug in the numbers straight into here, you can do that. So when I put this into my calculator, I get 371.36. And since we're talking about how many college students do we need in our sample, we always round it up. So 372 students. So that is the minimum sample size to get a margin of error of 5%.
Once you round down.
You always round up. Whenever you're talking about how many people does it take, if there's at least, because if you round down to 371, that's going to give you a margin of error that's not 5%. It's going to be a little bit off. Any other questions on that one? Okay, then at the bottom we have margin of error for means. So you'll see now we're using a t-distribution because it's means, and we're using the standard deviation for means. So our thing to remember here, how do we find the critical value on the t-table? We have to look at the degrees of freedom and then find the percentage and match those up. Well, how do we get degrees of freedom? Sample size minus 1. But we don't know our sample size. That's what we're trying to find. So we don't know the degrees of freedom because we don't know our sample size, so we can't look this up. So what we do is when the t critical value is unknown, because the degrees of freedom is unknown, then you can approximate by using the z critical value with degrees of freedom infinity. So if you're looking for sample size, you just use the z critical value, whether it's means or proportions. So again, if we wanted to solve this for n, we would first divide the margin of error divided by that t critical value would equal s over square root of n. Then to solve it, we can solve it as a proportion, just cross multiply and solve. So margin of error times square root of n equals s times the t critical value. Then we would just divide by the margin of error. And then square each side. So that's what we're going to do each time to solve for n. So, for example 2, we have a pizza shop owner. He wishes to find the 95% confidence interval estimate for the true mean cost of a large pepperoni pizza. How large should the sample be if she wishes to be accurate within 15 cents? A previous study showed the standard deviation of the price was 26 cents. So this 26 cents is our standard deviation. This 15 cents is our margin of error. We want 95% confidence. So our T critical value, we're going to use our Z to estimate it. So for 95% is 1.960. Are we okay with where I found all of those values and what they represent? Sort of.
On the yellow on the exit.
Okay. All right, so we're going to plug into our formula. So margin of error equals our critical value times S over square root of N. And we're just going to solve for N. So I'm going to divide by this 1.96. Then I'm going to cross multiply to solve that. And divide by 0.15. So I get square root of N is all of this. So to get N, I square both sides. So I get 11.5419, so I'm going to round up to 12 pieces is the minimum sample size. Okay, so this is going on page 78 in your notebook. Your notes. Page 79 is your problem set, so I'm going to give you guys the rest of the time to just get that problem set done.